during the first half of the 20th century in the UK, where I grew up, there was an intriguing and slightly odd collectible. And it was a series of illustrated cigarette cards that came with each box or packet of tobacco. And when I was a little boy, an elderly gentleman gave me his collection. And my favorite by far among them was a series called Romance of the Heavens. And these paintings had been done, all original paintings, in 1928. And they were some visual knowledge and representation of what we imagined contemporary astronomy to be at that time. And among the cards is a spectacular one, and it is titled Canals on Mars. And I love it that this was presented as scientific fact, or at the very least, likelihood. So in the 1920s, we thought that canals on Mars, possibly constructed by some sort of intelligence, was a fact, or at least likely. And I feel that that painting and that idea really illustrates how much our views of the red planet have changed in a relatively short period of time.
I totally agree. And what's interesting about that from being an analog astronaut is that I've actually lived in 3 Mars simulations here on Earth. And so the first one, we talked about the high seas habitat. And so the high seas habitat is located on the big island of Hawaii, and it was established in 2013. And I was part of the very first crew to live in this habitat, and it was a Mars simulation. It was a 4-month Mars simulation. So yep, I lived in this dome for 4 months with 5 other individuals. And we were there we were acting like we were living on Mars because we want humans to go to Mars and explore and kind of finish that or continue that legacy of our fascination with the red planet, right? And so when we, as analog astronauts, live in these Mars simulations, we're trying to figure out how humans can survive long duration space flight. So we're talking 2, 3 years, 4 years to Mars. And there are a lot of challenges with that. And so I just recently, Jeff, I went back to the high seas habitat in 2020 with an all-female crew. And so I lived in the high seas habitat, and this was our patch, the Sensoria mission, and just pre-COVID, right before COVID took over. And I want to give you this patch.
Oh, thanks. I remember when you were there. I remember the very joyous tweet when you all emerged together. But there was some great footage posted of you living and working together in the habitat. I must say, I think it bodes fairly well for the concept of long-duration spaceflight and also off-world habitats, that you and other analog astronauts have managed to get along so well and really you're paving the way. This is critical research for the future.
You're right. We are paving the way for Mars, but actually the real heroes right now are the robotic spacecraft that are on Mars, circling Mars, really laying the groundwork for humans. And one of the people who is, you would call him the robotic master of Mars, would be Rob Manning. He is the chief scientist at the Jet Propulsion Laboratory, and he has spent over 35 years working with robotic spacecraft exploring Mars.
And together with Rob, you're going to hear from Rod Pyle, who is an extraordinary science writer and also the editor-in-chief of Ad Astra, which is the National Space Society's official print magazine, a beautiful publication which is published quarterly. And in fact, one of the great perks of membership in the NSS is the subscription that you receive to this award-winning magazine. So if you've been intrigued by some of the topics that we've spoken about so far in A Day in Space, and you'd like to know more about really the nuts and bolts of spaceflight, how it all works, how we got here, where we're going, this is the book for you. Space 2.0 by Rod Pyle. It is a contemporary, meticulously researched, beautifully illustrated, really fascinating work that will make you your own expert on contemporary spaceflight in no time. So now we know you're going to enjoy this talk with Rob Manning and Rod Pyle. It's time for Exploring Mars.
I have a bone to pick with you.
Just one?
Yeah, well, one big one and
yeah.
some smaller bones.
Yeah.
You know, for thousands of years, humanity has spent a lot of time trying to figure out, to put a face on Mars, okay? And we spent a lot of time and energy making this planet a fantastic, wonderful, interesting thing.
Yeah. Yeah.
And then the scientists came along and kind of just messed it
the whole
all
thing.
up. Yeah, so.
Sorry.
So just to sort of frame this, if I may, with your indulgence, on my side, we have heart, we have wit, we have charm, we have charisma, we have a lot of things. And I would sum that up in this quote by Carl Sagan, who's a really wonderful guy. For small creatures such as we, the vastness is bearable only through love. Isn't that nice?
Yeah.
It kind of gets you right there, doesn't it? Now, on the other side, we have the scientists. Cold, shriveled, calculating. And by the way, he's an engineer, but they're kind of the same thing.
Yeah.
So for those, we have a quote by Charles Darwin. A scientific man ought to have no wishes, no affections, a mere heart of stone. And I've known Rob for a long time, and he's exactly that. So that's why we're up here today. Actually, he's a warm, wonderful, endearing guy, but for today, he's going to have a heart of stone for us. So we're here today to talk a little about these two sides of Mars. So I'm just going to kick off with a little bit of a historical introduction. For a long time, Mars was a deity. So long before we had fire, even, people looked up in the sky, and they saw this weird red object in the sky, and it looked like a star, except that stars twinkle a little more than planets do. So that was kind of weird. And it moved from night to night, it would be in a different position amongst the starry background. And that confused people, which, by the way, is where they got the name planets or plenates, which is Latin for wanderer. And then finally, every couple of years, it would do this weird kind of S-shaped pattern in the sky if you watched it day after day after day or night after night because of the changing alignments of the Earth and Martian orbit. So they knew something was odd about this red star. More remarkably, however, was the color red. So if you're living back in Og the caveman's age and you see the color red in the sky, what does that bring to mind? What associations does that bring to mind? Something you see a lot back in those days. Blood, when some saber-toothed cat would, tear apart your companion and haul them out of the cave. Fire, which is something that had been invented at some point and reminded you of that. And then with those associations came death and mayhem and war and so forth. So Mars generally wasn't a warmly regarded god, but at least he was a god. So we'll just run through a couple here. In Egypt, he was Hardashur, or Horus the Red. He's the one that looks like a falcon with the big red thing on his head. And if you had to carry around a red ball on your head for 5,000 years, you'd be grumpy too. The Babylonians, he was Nergal. That's the guy there on the left with the wings. Just look at him, I rest my case. You know why he's an angry guy. In Greece, he was Ares. And Ares is interesting because the Greeks didn't really worship warfare. They didn't revere warfare the way the Romans later did. To the Greeks, Ares was just kind of a jerk. He was the guy that came to your barbecue and kicked over the table and started hitting on all the women, and he was just a very unpleasant guy. You didn't like Ares much. But he was necessary because you have to have war to protect yourself against the bad guys. But here come the Romans, and they finally name Mars Mars, and they think he's just the greatest thing since sliced bread because what do the Romans want to do? Conquer the Western world. So that made a lot of sense for them. Then in the 1600s, Galileo gets his first telescope, turns it on the heavens, looks at Mars, sees a little disk and says, hold on, this isn't a god, this is a place. This is a place in the heavens. It's another place like Earth, perhaps. And of course, the church immediately said, speak of that again and we'll tie you to a stake somewhere and set you on fire. But he did continue to push his case. And in the mid-1800s, mid to late 1800s, we had Giovanni Scaparrelli.
Scaporelli.
I got that right, Scaparrelli, yeah. Thanks to the Italian menu update. And he came along with a larger telescope and started actually studying Mars, thinking of it as a planet somewhat like Earth. He could see certain features But remember, he's looking through a telescope. It's a wavering image because the atmosphere moves and flexes and changes. So you're still having trouble seeing much other than a red splotch with some dark spaces on it. But in his mind, these represented possibly forests, it could be oceans, it could be a lot of things. Unfortunately, he started seeing lines on the planet and called them canali, which is Latin for channels, which channels can just be trenches, right? But when English speakers heard canali, they said, oh, canals. Oh, so they're built by people, right? Scaparrelli, being a smart marketer, said, maybe. He didn't deny it, he didn't promote it, he just said maybe. So now we get this idea coming along of an intelligent race there building these things. Then here comes Percival Lowell. Now he's got a larger telescope. This is how we can see Mars through his telescope. Now we're getting somewhere, 24-inch scope, clear image of Mars. He goes bonkers and he starts drawing canals all over the place. Now it's interesting, if you overlay this with a map of the human retina and the capillaries within that retina, you very quickly see, we think, that because of the lousy coating on his optics, which is essentially none, and they reflected a lot of light, that these guys spent 20 or 30 years mapping the capillaries in their eyes. Fortunately, they're not here anymore, so they don't have to hear that from us. Be that as it may, I contend that they were still painting a very nice picture of a planet where we might have some distant relatives. So Lowell starts writing a series of extremely popular books about the civilization on Mars, doing a little bit of interpretive extracting, a little bit of imagining, and by the time he's done, he's basically saying that there are definitely advanced beings there, way in advance of us. They have televisions in museums, he said. And of course, 1905, 1910, nobody even knew what a television was, so he was a little prescient that way. The press ran with it. You would call this clickbait now. Back then it was just called journalism. And came up with this wonderful article about Mars is peopled by one vast thinking vegetable with a stalk about 8,000 miles high and a giant eyeball on top.
Hey, that's science speaking, cold-hearted science.
Yeah, but you know what? That's still a neighbor of some kind.
Yes, it is.
And he's got incredible vision.
I love the giant stalk.
Yeah, so if you're ever being stalked by your neighbor, now you know where that term came from. So the press ran with it, all kinds of stories. H.G. Wells, of course, writes famously The War of the Worlds, when the Martians come here and try to take us out until they catch the sniffles and die off. But all through the 20th century, we now have this evolving body of lore and fiction about Mars. So in the early 1900s, we get A Princess of Mars from Edgar Rice Burroughs. He did a whole series of Mars books. Swords, sandals, robes, beautiful women, big hunky guys.
Of course, they would evolve the same way as on this planet, and that much.
Why not, I
Why
say?
not?
Because at that point, we didn't know.
That's
thank
right.
goodness, and ignorance was bliss.
Ignorance is
By
bliss.
mid-century, we had pulp magazines. That's a Martian there,
Yeah,
and
they're
Martians
like
have really big chests because the air is thin. And they're covered with white downy fur because it's cold, and they have big ears because the air is thin, and the sound doesn't travel as well.
That's pretty smart.
So we'll see. That was science right
Yeah,
there.
science.
Then there was, I don't even remember where I got this illustration, but it's a Martian couple entertaining friends while heating dinner in their magic cooker. Somebody foresaw microwave ovens. So Mars was looking like a pretty cool place. So the idea at this point, really up until the late 1950s, although more and more scientists were pushing back on this idea, the thought was that despite the fact that the telescopes didn't show us much, despite the fact that the spectroscopes were showing an environment that didn't look kind to human life as we know it, there was still a chance that we would go there one day and meet this neighboring species, smarter than us, a peaceful global government that we can learn from, and this idea that there was somebody else in the cosmos like us that we could go play cribbage with, which made a lot of people very happy. Now, the next step was to go there and meet these folks, because clearly if they came here, they'd try and wipe us out with heat rays, and we didn't like that. So Werner von Braun, the famous German rocketeer who, well, he was most famous for the V2 rocket, which wasn't very nice, but we got over that, and we brought him over here and had him build our moon rocket for us and get us to the moon. But before that, in the late 1940s and early 1950s, he wrote a really horrible novel called Mars, A Technical Tale, complete with a jaguar, tawdry romance, strapping young man, and a fetching young woman, and it was so bad that it was not published until the 1990s. But there was an appendix to that, and by the way, von Braun,
Yes.
engineer. Yeah.
Engineer.
So, but there was an appendix to that book which had a technical rundown of what a Mars mission would look like. So he published that a couple years later as Das Mars Project, or the Mars Project, and basically came up with this idea. We're going to make an armada, military style, just like a naval fleet, of ships that would go out to Mars. There's 10 of them. 3 of them are crewed. The other 7 are cargo only. And they're going to glide to the Martian pole, slide to a landing, take an expedition by tractor down to the equator. Because after all, how hard can it be, right? Just ask the engineers. And then the other ships would land. Everybody would party on Mars for the better part of a year and then go home. And it all looked pretty good until somebody came along and said it wasn't. So that could have been our Mars mission, but that's not what we got, is it, Rob?
No.
Because soon...
Well, to be fair, Werner Von Braun, he was a terrible writer, but he was a good engineer in his day, and he was remarkably practical. So this idea of sending 17 astronauts to Mars on a 130-meter wingspan glider, landing on the surface seemed to make sense. And he put all the pieces together. He had figured out he needed a crane to lift it back up again, take all the astronauts to unhook the wings so he could launch it back as a rocket. So he figured it out. So this is the first time in human history that someone actually engineered a way to go from here to there, live there for a while, and then come back home. And he had figured that out. So he was a pioneer in that sense. Only problem is, he didn't know, they knew the atmosphere was thinner than Earth, but didn't know it was that thin. Had this actually been attempted, and they were attempted with the 1960s, they were trying to say, they would have landed on skids at somewhere between 500 and 1,000 miles an hour on an unprepared rocky surface. Wouldn't have gone well. Would not have gone well. Mars is quite a rocky place. So, so we didn't do that. Unfortunately, no one was killed.
But at the time, we didn't know that because you guys hadn't come along and ruined it yet.
Right. Yeah, because we need to send robots there to find out if it's safe to send people there.
And the first one was?
The first one was the first Mariner spacecraft that flew by. The first one was a Mars flyby in 1964. And it took a small number of pictures. 22 pictures. Very low resolution, black and white images, click, 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 click as it went by. And revealed a beautiful place full of greenery and blue oceans and giant stalks.
Sarcasm is not appreciated.
It turned out Mars was a place.
So that's the swath, by the way. That's how much of the planet. So while they were ruining our good time over on the side of the romantics.
Yeah.
Let's hear it for the romantics. Anybody?
Yeah.
Wow, nothing. Okay. 2. Good. Okay, we'll talk later. So they did give us some results about Mars. I'm sorry, I shouldn't be pointing that. I should be pointing up here. That made us pretty unhappy. Yeah, well, it's burning out my retinas, but I can't see it there. Anyway, there's a swath across the planet there, right?
Little stripe.
That's all it photographed. 22 images, very low resolution. So that's what they look like.
That's it. And so these pictures came to the Jet Propulsion Laboratory in 1964. In those days, we didn't have an easy way. We didn't have digital printers or anything like that. It had to be kind of put together. So the images came down as vertical stripes, and some engineers at JPL and the radio organization group were impatient. They didn't want to wait for all this processing this data in order to get a picture. So they happened to know that, and this was talked about the other day by Natalia, right, about in her Rocket Girls book. They actually literally, and we still have this at JPL, this big stripes of paper with numbers on them, and they knew the numbers corresponded to different colors, so they took colored pencils and pastels and colored them in like a coloring book. And on the left is the picture that they created, and it's the first picture that went out to the press, irritating the public outreach people and the scientists enormously.
And the romantics.
And the romantics, and that picture that it was sending was the one on the right. So the right was the actual picture. So the one on the left is the first close-up picture of Mars ever created with colored pencils. And it still hangs at JPL to this day. But that just, further revealed that, this wasn't, it's kind of a funny looking place. It's not that interesting.
Well, it's a little unfriendly, isn't it?
Time.
It looks an awful like that, because you go to the next slide.
Yeah, look at
and
that.
And that looks like the moon, doesn't it?
Darn it. Someone painted the moon red. Bunch of craters, dull, lifeless, no canals, nothing. And for the romantics of the world, they were all bummed. The scientists loved it. We thought it was the coolest thing. We're learning about a foreign place. We get to go there and learn something and learn about the history of the solar system. After all the planets were built together as one giant, from a big giant nebulous disk around our sun 4.5 billion years ago. Yes, we can learn more about how that worked and how it might be different elsewhere.
And crush the hopes and dreams
Crush
of those of us that wanted more. So at that point, it was a pretty low ebb, and I remember this because I'm old enough to remember this. Well, we both are, frankly.
Yeah.
I was a kid when Mariner 4 flew past the red planet, and up until that point, I was reading a lot of science fiction because I was that kind of kid. And at that point, we were still thinking, there's a chance. They can't prove there aren't canals yet. They can't prove there aren't at least forests. Okay, probably not advanced beings because we're not seeing any radio. We're not getting any I Love Lucy reruns from Mars. That's unfortunate. But maybe there's eight-legged thoats running around like Edgar Rice Burroughs saw. You can't prove it till we get the close-up pictures. That probe went by, kaboom. Our little red planet empire was smashed to red dust. However, science does give back. So 1971, Mariner 9 goes into orbit around the planet.
And what happens?
You have much improved instrumentation, and you fly right into a dust storm.
Yeah.
Which looks like this.
So you get to Mars, all you see is the top of volcanoes. And it was like that for months, waiting for this dust to clear. It turns out Mars kicks up these global dust storms once in a while, and it's very irritating if you're a solar-powered rover, or if you're looking from outer space, looking down and trying to see the surface, and there's all this dust. And so it took a long time before we started getting pictures. But we did get pictures of this from orbit, looking at Mars, and it looked like that. And God, look at that. What's that thing? What is that thing? They don't have those things on the moon. That you won't see many canyons with clearly formed by some sort of liquid. Now Mars did have a liquid, but it was lava rock. Liquid lava. There's lava tubes on Mars. You can see lava flows, but lava looks very different than water. And so, you know what? Maybe there's something else going on here.
So I'm losing a little ground, but could that be a canal?
Sure.
Thank you.
Whatever you say.
So it's a wandering canal, clearly confused by somebody who's been smoking something that we won't talk about. But it appears to be made by water. So at least the scientists have maybe given us back water, although there were still those arguing that this was wind erosion.
Yeah.
They weren't clear. It might be a volcanic formation.
Yeah.
Then you got this.
Oh man, the solar system's largest volcano. It would span, if you plunked it in the middle of the United States, it would go from the Rockies all the way to Iowa. I mean, it's even further. It's a big volcano with a great big caldera in the middle. It's so big that it sticks up above the atmosphere. So it's gonna be a long time before we parachute on that one. It's so big though, and it's much more. In fact, it's very much like the kind of shield volcanoes you will find in the Pacific, like Mauna Kea on Hawaii. Which extends deeply in our ocean, but this is vastly bigger than that. If you're walking on the side of that slope of that mountain, though, you barely know you're on a hill. It's got a very gradual slope. You could just walk all the way up there. But it was fascinating. And so the question is, wow, where did that come from, and why are they there? Big mystery.
Weird planet.
Weird planet.
But still not the one we wanted. But bit by bit, my side got to claw its way back. So now in 1976, we send the Viking probes. This has been in the planning for a long time. These are 2 orbiters and 2 landers, big, heavy, expensive, wonderful program. I snuck into Caltech to see it because they wouldn't let the public in, but I knew where the steam tunnels were because I grew up in Pasadena, and I was able to see these first images come back. It was incredibly exciting. And now we're on the surface of Mars, so we're not taking pictures from orbit only. We do have orbiters, but we're finally taking color pictures on the surface of Mars, and we're hoping to see something interesting. What do we find?
We find that it's
dead.
No green man. If they're there, they're hiding behind the rocks. But they never seem to come out. When we analyze the surface, what do we see? We did some chemical. We were smart enough to bring life detection equipment, 3 different instruments on each of the rovers. Each of the landers, and we scooped up the soil and nada.
And got this. Wait, hold on. Not there.
Yeah, right there. So
excuse me, but they go to Mars saying, okay, we're going to have a life science package.
Yeah.
Lots of arguments because scientists and engineers love to argue and hate each other. But we want to have some life science experiments. They finally come up with these experiments that are basically predicated on the idea, which, as I recall, Norm Horowitz was not very happy about, he was the chief scientist.
The scientist in NASA, yeah.
Which was, okay, microbes on Mars will behave like they do on Earth. So if we put this one in some dirt and squirt some chicken soup on it, it'll eat the chicken soup and metabolize, and
sterile
we'll
chicken
get
soup.
microbe farts out the top, and we'll know that there are microbes in there.
See, you have to just
Well, you
smell
didn't.
for, bug farts.
Another one was going to just inject just straight water, right? And
Yeah,
look for,
right.
These are looking for radioactive residue. They have traces in there. So so most of these experiments showed nothing. However, one called the labeled release experiment, very passionate scientist ran it named Gil Levin, did come up with a result, and that's what you're seeing on the screen right here. Mm-hmm. Explain that away, if you will.
We can't. There's no explanation. There is growing explanation. There's been a family of them, but this has been a very contentious point. 2 out of the 3 instruments said Mars is sterile. And by the way, it makes sense that Mars is sterile. Why? When we get there, you find out there is no oxygen. Why is there oxygen on this planet? Because we have plant life pumping it out every day. If those plants got turned off or were shut down, our oxygen would be gone in just a few years. It wouldn't take that long because oxygen is very reactive. So in fact, what happens is oxygen that's on Mars reacts with the rock, the iron of the rock, and turns it red. That's why it's red. So there is no oxygen, there's no ozone layer, which means the ultraviolet light from the sun comes streaming down. At least these bugs have good sunscreen. They wouldn't be doing very well. And on top of it, there's no magnetic field either. Mars is a little bit smaller. The inside of Mars doesn't have the big churning iron core that we have. So there's no magnetic field, which is like a force field. Like in Star Trek, there's a force field. Earth has her own force field.
Of course I know.
Yes. So yeah, you wrote for it. Yeah, you put the force field in there.
No, because I'm a geek and I watched everything. Go ahead.
So Earth has this force field. The force field blocks particles from the sun, from deep space, the cosmic rays that come from black holes and spinning, rotating black holes and quasars and pulsars around the. So did you know that those things stream through your body right now? And where are they coming from? They come from a squirting, spinning black hole at the center of some of the galaxy, and it's coming right into you right now through this room as we speak. However, there's not much of them because much of them have been deflected. On Mars, there's a lot more of them. There's a lot more particles from the sun. It's bad for living things, unless you live underground. If you're 12 inches underground or a couple feet underground, you're okay. But if you're on the surface, it's not a good place to be.
So you're making me feel all warm inside with this discussion about galactic particles. So basically what we've done is traded a planet covered with canals and critters and people for rust, is what you're saying.
For rust,
for rusted rocks.
An old, rusty old planet.
Thank you. By the way, I will point out, this is Viking from overhead. That little radial sweep you see is how far its manipulator arm could go. So for all the life science they're doing, the samples are in an area about the size of a small runner carpet in your hall.
Yeah, the best coffee table.
So a little extrapolation at work there, but I'll give you that. So the orbiters in the 70s take this picture of a region called Cydonia, and by golly, what does it look like? Looks like my Aunt Maud with no hair when she had her wig off. And it was kind of hard to explain away, and people got very excited, and all of us will make extrapolations because we want to see certain things. And it's pareidolia is the word I was trying to remember. The human desire to put things into familiar form, especially to form human faces, is kind of a tribal trait we have. So it's why when you're at the airport looking at the sea of faces of people you don't know, you see somebody that looks like the person you're looking for, mom, dad, your brother, whatever, and suddenly a little bing, you get this little opioid squirt in your head, and it's saying, oh, you recognize this person. And I recognized Aunt Maud right away.
So how did the ancient Martian civilizations know about Aunt Maud?
Through magic telescopes.
Yeah, magic. So yeah, it does look like Aunt Maud.
But
it doesn't look like that in reality. The amazing thing about the brain is that we like making space. You can still see Aunt Maud in this picture. This is a high-res image of
Aunt Maud looked like that later.
Yeah, so she's got a little older at times, So the real view of this hill is that, our brains are good at making things. And so many people said, Rob, there's got to be something real going on here. Certainly there'd be ancient civilizations. And the great thing about Mars, it's like an ancient museum. The rocks, if you see a rock, if you're on Mars, next time you go to Mars, look at this, check this out. When you go there, kick a rock over. That rock, chances are that rock has been sitting in that position, waiting for you to kick it over for millions, if not good fractions of a billion years in that position. That's how ancient it is. You try to do this on this planet. That rock that you kicked over on your hike out in the prairie, probably was put there at best, latest, a few thousand years ago. That's for really old ones. Most likely much sooner than that, because we have rain, erosion, and plate tectonics. On Mars, all that stuff has come to a halt. It sometimes snows, and on Mars during certain times of the year, but generally speaking, Mars has been this wonderful rock museum for a very long period of time. The only thing that really moves things around are these meteors that come along and slam into the surface of Mars and throw up some more rocks that you can kick over when you're ready, when you go.
So you're not selling me on a very exciting planet yet. However, just to bring things up a notch, they sat around for 20 years and didn't look at Mars at all. So we were able to sit back and fantasize about Aunt Maud and why she was on Mars.
I think we bored people, with a dead red planet.
Well, I think you kind of ran out of gas with Viking and Apollo, right?
Yeah. Viking was very expensive, and the nation had other things to do. This is a good time maybe to build a space station and a space shuttle to get to it, and that's what NASA did.
And it was really expensive. But after that,
1997,
NASA came back with Mars Pathfinder, and here I will tip my hat to you because that was your mission.
Yeah.
And it's a very big deal. So why don't you walk them through it? We got a little movie here.
So
show the dynamics of it.
We didn't have much money, so we were given the budget of a major motion picture to come up with a low-cost way to land on Mars. We couldn't afford the rocket thrusters, so we came up with these airbags, and my friend Tony and I and others there bouncing around the room in the 4th of July, 1997, where we bounced a little Pathfinder on the surface of Mars, where inside it was a little rover called Sojourner, the size of a microwave oven. You guys remember that? That was, it's starting to be, that's 20 years ago. Whew, oh my God. And so we learned how to drive a little rover on the surface of Mars. Because, when you're stuck inside lander, you're looking around these pictures and you're reaching out this far and you go, geez, what's over there? You can't really strain your neck at all. You just look, same picture today it was yesterday. And so a rover, on the other hand, could go out there and explore. We could go over the hill. Now this rover explored the area about the size of this room. So it was just an experiment. In fact, we couldn't get that far because it had to stay within walkie-talkie distance with the lander that brought it there. But it worked, and we kind of proved to the world that the sunsets are kind of bizarre. The sky turns, instead of turning red, it turns a little purple, and the kind of a bluish sun actually at times. And my teammates and I, oh my God, who is that old guy?
Nobody's got a really dark beard.
Yeah. So I was in charge. I'm chief engineer. So I was giving the play-by-play at how to land the thing, and it's very nerve-wracking. So you see us, these people jumping down, screaming and cheering. It's because
I get to keep my job.
I keep my job. No, it's because it's really hard, and these things are very complicated devices. 80-some pyrotechnic devices all have to work. Software has to work. Everything's automatic. It has to all work. We have to test it, and we can't test it on Earth, irritatingly enough. So because you can't. Earth is so different than Mars. You just can't we'll try landing it here on Earth. That's how it does. It doesn't work. Even airbags don't bounce. You can't. If I bounce them out here, they break. I have to take them to the world's largest vacuum chamber in Sandusky, Ohio, where the Plumbrook Station. They have a 100-foot tall by 80 feet, 120 foot tall, 80 foot wide vacuum chamber where I can bounce airbags on rocky, big wooden rock platforms full of bolted round rocks. And so I have to do these very special places, but it's really hard to test this stuff. So the first time we're testing it is on Mars in front of live feed to the CNN. Very nerve-wracking. So CNN, because of that, our test works. We're extraordinarily relieved that we didn't make a mistake, because if it doesn't work, it's because we screwed up. And so the CNN gets to capture us, in tears, in relief.
So, but most of us are used to thinking about NASA spending big dollars. We hear about the federal government. How much was the toilet seat that was so famous? $5,000?
Yeah.
$9,000, something like that.
Yeah.
You hear these stories. However, there is one thing you can test on Earth, which is how to drive a rover in sand. Where did you get your sand for
Home
this
Depot.
program?
Home Depot.
Yes.
Home Depot. We bought.
And where did
place
you
in-
build your test bed?
We bought right in our conference room.
That made some people
This
happy
is a
down the
conference
hall.
room, so it has raised floors. And I said, well, if I buy a bunch of plastic and lower it down, it won't fall in through the raised floor. And the only thing we wanted to put airbags in there, but we have these little sprinklers. So I was constantly inflating the airbags in there, and of course they wouldn't inflate completely because they're 17 foot high and the ceiling is only like 8.5 feet tall. So I'm constantly worried of this bumping into the sprinklers and setting off the fire alarm in there. But it was very low cost. I deflate the airbags. I use my home, my leaf blower from home, and it works. It works. Leaf blowers do fine. Now on Mars they don't work so well because they're too slow. You need to inflate them in about a quarter of a second. And so our airbags are inflated in a quarter of a second. By the way, the airbags fit in here, they'd fit in here, but they're 17 feet high, and the whole thing bounces. In fact, it was designed to bounce over a 9-story, 10-story building. In Mars, it only bounced about 7 stories. Not very much. And it bounced about 1 kilometer on sharp rocks, and it didn't rip. Yes. So.
And that's rocket science. So this is what Pathfinder looked like deployed. So once it landed and bounced around for a while, the airbags deflated and retracted. Then you have the center spacecraft structure with the pedals that come down, and the rover drove off and did amazing stuff.
Yeah, and it lasted for 3 months. And we didn't learn a lot about Mars because it was a low-budget mission. It was less the cost of a major motion picture, which we were proud of. But on the other hand, we realized that this was, because we were trying to see, is it possible to do a low-cost mission? And we proved that yes. And was it possible to do robotics, mobile missions? Yes, it was. We just have to instrument it and make it a little bit bigger. The one thing I learned about a little rover on Mars driving around, when you're driving around Mars and you're only this high off the ground, rocks that are this big are really scary. And so the rover's constantly in fear of big rocks and had a hard time getting around. So we said, it needs to be a little bigger. Maybe the size of a coffee table as opposed to the size of a microwave oven. So that's what we kept thinking after that. And
but it got there, and that's not a given with Mars Project.
Yeah, and you can see that. So we here at Von Braun thought we'd be landing people on Mars. Meanwhile, we're sending robots, and we're having humans are saying robots, and we're having a rather abysmal success rate. Still, even to this day, only 50% of Mars landers actually work. Yeah, good news. I need wood. So far, so good for me. Yeah, my team and I have done. Ours are the blue ones. The red ones have failed. The most recent was the Europeans' Scaparrelli lander that landed in October or November of 2016, a couple years ago. It didn't do so well. It crashed. By the way, it wasn't just they didn't do a stupid thing. But it was a very subtle design feature that many of us wouldn't even thought about. In fact, their failure, we were like, oh my gosh, we didn't think about that either. How come we haven't failed yet? We got lucky. Oh, good. Oh, shoot. So that's how we learn, by the way. Because it's not that much that we make mistakes, and we do make mistakes. All humans make mistakes. It's just that it's bloody hard not to make a mistake. That's the problem.
Well, if I could just step back a couple of decades, we're talking about the success rate being low. Let's contextualize that on a nationalistic basis.
Yeah.
So since 1960, the Soviet Union we had a space race going on, right? So we were aiming for the moon, they were aiming for the moon with people, but we were both also aiming all over the solar system with robots. So NASA would build and launch these things in pairs because it's smarter to launch them in pairs than singly, especially then, because robots weren't that reliable.
Yeah.
The Soviets were hurling these things out like baseball pitches, seemingly like every 3 weeks. So they've been trying for Mars since 1962.
62.
And as of now, the score is 0.
Let's see, 1, 2, 3, 0.
Yeah.
There's
a point something. They did have one lander that transmitted for 30 seconds.
They were very successful at Venus, which is also a very
Mars is
different
still
world.
0.
Yeah. Mars is 0. Venus did it pretty good. And they're the ones that have landers that survive this intense pressures and heat and sulfuric acid atmosphere to make it super Venus. So I give them they got to give them a nod to Venus there.
Yeah, that's why Aunt Maud isn't on Venus.
That's right.
So we're going to milk this one forever. So then that rover was so exceptionally successful at 250 million, or 150. Less than a movie.
The flight vehicle, not including the rocket, is $150 million.
Yeah, so less than a movie Titanic, as you like to put that.
So it was. So we actually had a Mars failure, Mars Polar Lander. It was one of these faster, better, cheaper missions, very much like Pathfinder, but it was just a little bit too tight, and so they turned. To save money, they didn't use a radio to communicate like we were doing for Pathfinder. So they turned the radio off, and the expectation is after it landed, it would turn the radio back on. And so I'm in the control room. This team, I was in charge of the design, but I was kind of looking over and kind of being an advisor to them. And we're staying there, looking through. Now we have no data, so all we know that it's turned its radio off, and it should be going through its entry, descent, landing sequence, and it's supposed to land, and it's turned its antenna toward Earth and beam back a signal. So we know exactly what time that signal's supposed to be active. We're watching the countdown clock: 5, 4, 3, and we're looking for. We had radio There's a little frequency analyzer looking for the tone of the carrier signal. A single tone coming back. Ready? 5, 3, 2, 1.
2, 3, 4, 5.
Okay, working in Pathfinder, I knew that if the signal doesn't show up when you plan it, it's not going to come back in 10 minutes. It may not come back for hours. It may not ever come back. I'm there behind the glass window, and the people who are operating on the other side of the glass, and all these cameramen are inside. I'm going to throw up. So I got against the glass and went. So I sneak out and go home, and I throw up. We've never heard from it again. We've got terabytes of image data taken from high resolution camera in orbit in that whole area, and I can't find the damn thing. It's there somewhere. I shouldn't say that. The dang thing. It's there somewhere. I know it. We aimed for Mars, and it's I don't know what happened to it. So we have many theories of about 18 failures. Anyway, with that failure, we were stuck. It was in 1999, December 3rd, 1999, and in the subsequent months, we figured out we had to brainstorm new ways of going to Mars, and one of the things we came up with in the months after that is modifying Mars Pathfinder to put that little thing, instead put wheels on the lander, get rid of the little rover, and take the center part of the lander and have it stand up and drive away. And that's what this is. This is a tetrahedral shaped rover. It doesn't look that way, but the reason it looks like a fly, a little bit with the solar panels, if you fold it all up and bring the wheels in like this, it becomes a triangle, a pyramid that fits inside those pedals you saw in Pathfinder. So it's exactly the same size as Pathfinder, except it's got wheels and it can take off. So we said, let's build this, let's do this, and launch us in 2003. Now, something you need to know about Mars, and if you ever become astronauts, some of you, are any of you future Mars astronauts, raise your hand. 1, 2, 3. Okay, you can volunteer, you can go. Yeah, good. Yeah, a bunch of, okay, so great. You need to know that if you miss the bus to Mars, you have to wait 26 months. The launch windows are 2.5 weeks long, and if you miss that window, you have to wait 26 months. Why is that? Because you can leave Earth anytime you want and go around the sun to get to Mars orbit. But Mars may not be there when you get there. Details. So you have to wait for Mars to come all the way around 26 months later to come back around again, so they meet up in the journey. And so that's why it takes so long. So that means if you can't be late. So we had 2003, they gave us a chance to build 2 of these things, and guess what? We launched them both 3 weeks apart, just either side of the window, and they were landed 3 weeks apart. And they both work, Spirit and Opportunity rovers. In fact, Opportunity rovers, one of those is still working today as we speak every single day on Mars.
14 years later.
Yeah, so
30 miles?
Is that the fist bump you're talking about? Oh, yeah. I'm on the phone with my mom. Oh, actually, no, my mom and my wife. They're back to my house, and I'm just talking. They're like screaming. So we were just getting our pictures back. It was a great.
Your wife's saying, "Yay, the hard part's
Yay,
over.
Yes, you can come home now finally." Yeah, and then guess what we find? So these are roving geologists. So, we're not looking for life. That's what Viking did. Looking for life, we discovered, was really hard. It turns out if life is unusual, if it doesn't come up and wave in front of the camera, it's really hard to detect, especially because it's possible for us to bring life from Earth with us. And that's not a good thing. And it's really hard to sterilize your vehicle completely. So these are roving geologists. And the cool thing is that we bounced, especially Opportunity, bounced into an area full of these blueberries. They're BB-sized, bluish little metal balls everywhere, as far as the eye could see, going out. And we looked around, there's a rock outcrops, and they said, what the heck? You know what? This was formerly lava rock. Now, if you take a lava rock on Earth and you put it underneath the ocean for a few million years, try this experiment at home someday. Put it on, these rocks will alter, the water will get in and change the mineral structure. The atoms don't go away necessarily, but the configuration does, and it changes from a lava rock into a different kind of rock. It's the strangest thing, and what's more, that water can leak in and forms these little, nucleate into these little balls, and so we got clear signs for this white gypsum and these balls made of hematite, a form of iron, that happens underwater. Wow, Mars was wet. Mars was wet for a long time, but how long ago? Well, clearly from the layers we were at, it happened a very long time ago, 3.5 billion years, only 1 billion years after the dawn of the solar system. Back when Earth was actually not a very habitable place, by the way. I wasn't here then, but I can tell you, it was not a great place. There was lava. There was very little, no oxygen. Actually, no oxygen in the air to breathe. It was very noxious. But Mars may even look something like this, Rod.
Well, I can see archaeologists in the far distant future that come from some other planet to Earth and go to an air gun or a pellet gun shooting range, and try the same calisthenics you just went through to explain all those little pellets, which look an awful lot like BBs to me, but you go ahead and knock yourself out. But you did give us water, which I appreciate. So now those of us who care about a living Mars get to see this vision, which is Mars a very long time ago, possibly in the distant future, which is a wet, watery Mars where life could possibly be present. However, we're not quite there yet. No. So what these smart guys at NASA did, I'll give you that, you're very smart, they designed the next mission, which was not going to look for life, but it was going to look for a habitable planet in the past.
Yeah, so the question is, so just because there's water doesn't mean it's good for life.
But I still want my canals.
Oh, look at those guys.
Yeah, just want to point that out.
They might have been there.
Okay, here you go.
So one way to go to Mars is, one thing you need to do is you maybe want to send a laboratory that actually does chemistry on your samples that you take from the surface of Mars and find out whether life was habitable, whether Mars is habitable for life. It wasn't too acid, it wasn't too salty. If all the ingredients were there, then maybe, or life as we know it, by the way, I'm being rather parochial here, life as we understand it on this planet could have lived on Mars. Single-cell organisms. Is that possible? We don't know. So we came up with this idea. In fact, this idea of lowering the rover up, my friends and I came up with it back around 2000, to be honest with you, a long time ago. And we worked on it, and gradually we learned that this was actually the least unsatisfactory way to land on Mars. Yeah, so in our world, there's no best. It's just the one that's got the least cons and the most pros, right? So we landed on wheels. Really cool. And it worked. We basically the idea of a helicopter mode, lowering it down. We landed us, and we had a great day on August 5th, 2012. In the evening, we were very relieved. You can see us there emotionally. Again, this is my fourth land, actually fifth, include the one that vanished, landing, and my fourth mission that I helped develop. I was the chief engineer for Curiosity, and it was a very emotional experience for us because we worked so hard trying to find all the mistakes we made. And the thing is, people look and says, well, NASA institution, of course it's going to work. How could it go wrong? You got to be kidding me. We're finding major design flaws or issues we had to fix even in the days and hours leading up to landing on our missions. It's bloody skin of our teeth. And I have to admit, there's a lot of stress trying to land something that's $2.4 billion on another planet, your money, that I don't want to break. And so, but we did. And we've got, over the years, it's now been on Mars for how many years since, well, that's 6 yeah, 6 years. Opportunity has just finished its 5,000th day on Mars.
That's 14 years, right?
Yeah, 14. Yeah. So check this out. So how long is a Mars day? You guys know about it? You know what Mars is like to be there? It's a very cold place. I mentioned there's no oxygen. I mentioned the air is super thin, only 1% the density of Earth, and the gravity is 3/8. So at least you get some benefit. We can run around like basketball players, and jump around. But the really one interesting fact. It's amazing. Because we're operating these rovers and we're trying to operate them, they're pretty much autonomous, but we have to give them instructions every day. So while the rovers are asleep, we're coming up with a plan for the next day. So that means we're in sync with Mars. What is a Mars day? 24 hours and 39 minutes, which means if you're a Martian or you work on a Mars rover project, you can sleep in 39 minutes every day. Isn't that great? I could use that. I usually use that 39 minutes every day. I tell you, I slept right through it. The trouble is you wake up in the middle of the afternoon, then in the late afternoon, then at night, and pretty soon your family's getting angry with you, never coming home. So the best is to take your whole family to Mars with you. That will work best. And so if you are going to Mars, you'll at least get some good sleep. But we did do this. We explored Mars, and the cool thing about this, so we landed next to this big mountain, right? Its mountain is almost as high as Denali. It's higher than Mount Rainier in Washington State. It's a big mountain right next to us. We landed right at the base of it. We thought we'd look, and we noticed it was like made of a layer cake. And even most of our mountains aren't layer cakes. They're volcanoes, or they've been pushed up. This is like a weird layer cake. And so we wanted to see that. So the lowest layers, like the Grand Canyon, would be the oldest stuff. So we landed at the very bottom, the oldest stuff. And it turns out we got there right away. We looked around, oh my God, are those pebbles? My gosh, those are river pebbles, and they roll downhill. There's a river that's 3.5 billion years old. Try to find a 3.5 billion year old river in this planet, and I dare you. It's hard to find because plate tectonics and wind and rain. And then we found another place. Well, looks over here. Looks like an old lake bed. Let's go over there. So we spent about a month going over there. Got over there. We drilled our drill, pulled out these dust samples, put them into our laboratories in the back of the rover. And sure enough, it was a lake. It was clay. Phyllosilicate clay. And what's more, that was not just clay. It was clay just like the ones on Earth, where it was not acid. It was fresh water. It was clear. It had a nice redox potential. So if you were a chemophile bug, you would be so happy living there. And it's room temperature. It's wonderful. There's an atmosphere. No oxygen. You don't need oxygen if you're a chemophile. So it's in a perfect place for life to be. We convinced ourselves that was our main purpose of this mission. And within just a couple months, we realized that we had gotten what we came for. We discovered that Mars was indeed a habitable place for life long ago.
A really long time ago, 3.5 billion years ago. And it may have looked like that then.
It may very well have looked like that. And it may have been, in fact, if you were an alien coming from some other solar system, you would come by and you'd go like, gee, there's Venus, no, that's still too hot. No. Earth, kind of a mess. Mars, that's pretty. You might find that Mars was the most interesting and most habitable, most trustful place to be. But what happened, our histories diverged incredibly. Because there's no magnetic field on Mars, the atmosphere got blown away from the sun, and voila, Earth turned out to be the place to be after all. This is the winning planet.
So now that we're becoming friends a little bit more, especially because he has some control over my job up there, they are coming up with a mission, which I like, which is Mars 2020, which is a rover that looks very much like Curiosity, but with more advanced instrumentation. Finally, first time since Viking, we have an astrobiology mission.
Yeah.
And we're going to look for?
We're going to look for life. In particular, we're going to try to look for dead bugs. It's like looking for fossils. We're looking for fossilized life. We don't think we're going to find living things right on the surface because of what I told you before. But if we dig down, we might find, for example, shale deposits or other kinds of preserved forms of life. And we're still doing it with Curiosity today is drilling. In fact, it started drilling again just recently after having a problem with our drill for a year. We figured out a workaround, we fixed it, and now we're going back and resuming our explorations on the surface of Mars with the drill on Curiosity. And this mission right here is going to be going in and taking core samples, not only analyzing them there on the rover, but packaging them up for a future Mars mission, maybe something you guys are going to design, or pick up even as astronauts, and collect. They'll be well documented, and we bring them back to Earth. We launch them on a rocket from Mars, put them in orbit in a little ball. The ball gets captured by an orbiting spacecraft, gobbles it up, flies it back to Earth, and drops it off. Maybe here near Des Moines? What do you guys think? Yeah, somewhere on Earth, on a parachute or something like that, just landed on Earth.
And then the microbes get out and wipe out humanity and all as well.
Oh, no.
However, so that's the robotic plan. That will be sometime in the mid to late 2020s. We'll go pick up these samples. At the same time, we've got folks, NASA included, but primarily private entrepreneurs saying, you know what, let's skip that part and just send the people, which of course, the guys like me, pitter pat, right? So if I'd come here 2 years ago and you had said, so what about this new space age? I would have said, be patient, it's coming, it'll be here really soon. But because, as most of you probably know, the Falcon Heavy, SpaceX's new rocket, flew a couple weeks ago, I can tell you that new space age is here. Because this crazy kid, Elon Musk, who went to NASA and the Air Force 15 years ago and said, I'm gonna build rockets and fly your payloads. Not knocking NASA, but basically they said, that's nice, get back to us when you've done something that you can prove. So he did. And he went back to NASA and they said, okay, we'll do business with you. He went to the Air Force. They said, well, we're not really sure yet. We got this other company we're working with. And he said, if you don't start letting me bid on things, I'm gonna sue you. And they said, okay, you're on. So now he's flying for them too. So he's had a great string of successes. Now he's got this big rocket, biggest thing in the American arsenal since the Saturn V, biggest thing in the world since the 80s when there was a Russian rocket that was about that size. And now we're flying very heavy payloads at about 1/5 the cost of the nearest private competitor. And this means exciting things will begin happening. Now, is he gonna put people on the Falcon Heavy? Well, he said he was. And then an hour after he flew it, he said, you know what? I'm not gonna. And we were at the press conference going, why not? And he said, because my next bigger, amazing rocket is coming along so well, I don't need to. I'm gonna be flying.
What's it called?
It's called the BFR, which is the big Falcon rocket, or if you work at SpaceX on the inside, it's the big rocket. But we don't use that outside of the company, right? And that thing will be able to carry upwards of 70 or 80 people to Mars at a time, somewhere between, he says, 6 or as little as 3 months, depending on what kind of propulsion he uses.
Wow.
Physics are a little gooey there. Here's a picture of it. It's the size of a Saturn V, except that it's a cylinder all the way to the top, so there's none of this tapering stuff down to a little 13-foot capsule. It's a great big rocket with a nose cone the size of an RV filled with people. Here's Elon's city. And by the way, when Von Braun wrote that science fiction book I told you about that nobody published till the 90s, the ruler of Mars, elected by a plebiscite, was named the Elon. Really? How's that one? You want to go on Coast to Coast AM radio and talk about conspiracies? Yeah. So one of the things that program will do, or probably before that, the Mars 2020 rover is going to do, is go up and look and see what kind of resources we can get from the Martian atmosphere.
Yes.
To make it easier to stay there and come back.
It's not just samples.
And build cities like
That's right, because we have an experiment on board our vehicle, which is actually going to, use Mars atmosphere to create, to take apart the CO2 and use it for good. And which is an experiment, because eventually we have scale. You need large, big ones to take the CO2, break it apart, and use the oxygen. Then you also need big pickaxes and shovels and caterpillars to tear apart the ice that's there. We found lots of big chunks of ice. If you break the ice up and melt it and boil it, and you can make it nice, clean water to drink. And so it's possible. Mars actually has resources to survive. It's just a lot of work.
So you're going to send machines up there to drive around, explore, and people to swing pickaxes and break up the ice?
Pretty much it. Yeah.
Okay, good. Yeah, so there's our city, which is not too far away from what I wanted, which is that.
Yeah.
Of course, we got our pyramids. You got to have your pyramids. So it looks to me...
those canals would freeze and boil away. Pretty hard.
I was just starting to like you.
Yeah, sorry.
Yeah. However, all that said, I think when all is said and done, we need each other.
We need each other.
Okay, so art and science can coexist,
Art and
is that
science
what you're
can
saying?
coexist. Yes, we can. Cheers.
Bring it in, Vic. Oh, man. Okay.
Hello, my name is Charlie Netschaum. I am currently a build engineer at SpaceX's Starlink, as well as chair of SEDS USA, which stands for Students for the Exploration and the Development of Space, a nationwide organization at colleges, universities, as well as high schools. Space exploration is important to me because probably three primary reasons. The first being, I think, the most obvious, the technology it brings and the betterment of society for a lot of what the space does, including GPS, weather satellites, I mean, the list goes on. Second is more of like a Elon Musk kind of answer. End of the world. It's very hard to stop an asteroid's momentum from hitting Earth, and really there are things lingering that can happen that we really have no control of, and the only possible solution is coming off this planet and trying to civilize another one, which is incredibly exciting. The third, I'd say, and it's a little more of a niche answer, is the ability of space to bring together a group of people. I mean, not even just within one country, but around the world. I mean, there's not really many industries where you can look up and see it. I mean, every child wonders what's out there. What are those stars? How do they work? Can we go there? And I think it's a very unifying industry, and that is why space exploration is important to me.